All right, here's a limiting reactant question. It says, consider the following unbalanced equation. They've got ethanol burning. 1.6 grams of ethanol burns with 10 grams of oxygen. What's the total volume of gas present? And that's sort of a tricky question, because really what I want them to ask me is what volume of carbon dioxide is produced. And as we'll see here, as you look down, that's what's figured out. But the question says, what's the total volume? So let's first go through the limiting reactant part, do the stoichiometry, and we'll return to this total volume part in a second. Okay, so I'm given 1.65 grams of ethanol, 10 grams of oxygen. I convert the grams of ethanol right here into moles. Perfect. And I convert the mass of oxygen right here into moles. Good. And then it looks like I don't see this anywhere, but I think what's happened is we've gone 0.0358, etc. moles of ethanol, and we went times 6 divided by 2, and that came out to this number, 0.1074 moles of oxygen required. But then when we take a look at how much oxygen there is, we've got tons of oxygen. Therefore, ethanol is a limiting reactant. Oxygen is the one in excess. Okay, good. Now, keep this number in mind for later. So now we'll just do stoichiometry with the ethanol. Okay, so find the moles of ethanol, step 1, done. Convert it to moles of carbon dioxide on the other side. So it's 4 divided by 2. And so you get that many moles, yeah, that's about right, of carbon dioxide. And then you use the ideal gas law, like this, to figure out what the volume of, this would be my volume of carbon dioxide gas that I have. So if that's what they were asking me for, perfect. Round that to some sig figs, we're good. But the question asks for the total volume of gas. So let's see what kind of stuff would be still in the container. Of course, we have the carbon dioxide, and down there we have what volume of carbon dioxide we have. The water is a liquid up here, so it's not going to contribute any gas. Let me go green for gas. So it's not going to contribute for gas. This one's going to contribute. The ethanol is the limiting reactant, so it gets all used up. So it's not going to contribute to how much gas is left in the container. But the oxygen, we got excess. We got extra of that. So that'll contribute to how much gas we have. So how much excess we have, or do we have? So here, in this calculation right here, we determined how much oxygen we would need to use up all the ethanol. So we would need to use up this much oxygen to burn all that ethanol. Okay, but I have this much. So I have 0.3125 moles of oxygen. And if I use up 0.1074 moles of oxygen, if I subtract that, that's going to tell me how many moles of oxygen I have left over. So it'd be 1, I think that'd be a 5, a 0, and a 2. So I'd have 0.2051 moles of oxygen left over. Okay, so now if I want to figure out what volume, I'm going to go back to that PV equals nRT. So V equals nRT over P. Volume is 0.2051 times 8.31. Sorry, I'm not putting units in. 314 times what was the temperature? 25, so that's 298.15. Over the pressure is 1 atmosphere, so that's 101.325 kilopascals. When we use the ideal gas law, you have to use kilopascals. Sorry. If you said bless me, thank you. Okay, so now let's do this on the calculator. Okay, when you do that on the calculator, it comes out to 5.0175, etc. liters of oxygen. So if I take my 5.0175 liters of oxygen, so this is of oxygen, and that was left over, right? It didn't react. And I add to it the 1.719 whatever, 8 liters of CO2 that got produced. If I add those, I'm going to get, what will that be? 14.8676, something like that, 6.7684, and round that off to whatever the sig figs are for the question. And that would be the total amount of gas in that container.